All media objects, for instance images, videos, etc., are stored in the media entity. This is pretty convenient as it lets us store media files in the database under a separate database table, which would be better for performance. There are pros and cons for storing media in a database. A pro would be that it works with clustering, as data is in the database and not on a specific server file. However, it might make the database too large and harder to back up. Performance is more complicated. It should be reasonable as long as table is separate. Historically, performance of blobs in the database was pretty bad, and there might be issues in some deployments or some database types, so this might be challenging. Both approaches would be simple, unless scaling is involved, in which case we'd need to store files somewhere. There is a common alternative of using a service dedicated to hosting files, either homegrown or in the cloud, for instance S3. Since the media object is separate, it makes sense to have it anyway, and if we choose to use such a service, we can include the file key for the cloud object instead of the actual media file. The media object itself is pretty simple. Just like the user object, we use a UUID to represent a media object. This is the file name used when uploading, which might be relevant if we let the user browse the files he uploaded in the future. The timestamp when the media was uploaded using long makes this simpler to work with, although date might be more convenient in a database. Role can be used to indicate the purpose of the image. For instance, if it can be an avatar to indicate the image serves as an avatar. Visibility is the privacy scope of the image. For instance, friends would indicate only friends can see the image, whereas public would indicate it's visible to everyone. This is the user that uploaded this media object. The data is marked as a lob, which lets us store relatively large objects. Notice that there is still a limit on file upload size enforced by the web service support in Spring Boot. The media object has a DAO as well. It lets us pass the media data back and forth through the service layer. As you can see, the rest of the code is only getters and setters. Nothing much. The object is relatively simple and only contains one small dependency, media DAO. We could potentially enhance it with additional data such as description, tagging, and even auto-generated content based on image recognition. But for now, that's enough. Before we go into the media DAO, we also need to mention the CRUD repository interface for this class. It's simple as we don't need any queries at this point. Now that we got this out of the way, we can look at the DAO. It's trivial too. The fields map directly to the fields of the media class in this case. The obvious exception is the user DAO object, which uses the DAO type instead of the user type. As we did with the user object, we have a default constructor and a convenience constructor. Both of these were generated by the IDE's completion suggestions. The rest of the code is just auto-generated getters and setters, nothing else. And with that, we conclude the media object entity.